IP version 4 basis. Imagine sending a letter. You need a street address and a house number. Street address here network and house number is host. IP versions 4 works similarly. IP version 4 format. 4 numbers separated by 3 dots, each ranging between 0 and 255. Like you say here. 1, 2, 3, 4. So 2 parts. Network portion, which is this part or that part, identifies the street network. And host portion identifies the house. The last part. Look at this table here. IP version 4 addresses classes. There are 5 classes for IP version 4 for IPv4. This is all ranges here. And example for each range. And purpose for each range. Like class A, purpose of it for large corporation and government. And this range, medium organizations. Class C for small business and home networks. Class D for multicasting. Class A for experimental reserved. Subnetting. Why we use subnetting? For reduce congestion, improve security, optimize IP address usage. Explanation. Subnetting is like dividing that big crayon box into smaller boxes, subnets, so that 1. Each friend gets their own little box, which is subnet, with just the crayons they need. No one gets confused or takes crayons from someone else's books. 3. It's easier to find the color you want because you only look in your small box, not the huge one. Big crayon box equal big networks, like all the devices in your house. And small crayon box equal subnets, like splitting mom's laptop, your tablet, and dad's phone into their own group. Here's a quick scenario. Scenario 1. Small office setup. Requirements. 3 departments, which is HR, IT, and sales. Each needs 20 devices. Use that, which is, okay, yeah. Use that IP address. Solution. 1. Subnet mask. 24, and we do this subnet. Here is 30 houses per subnet. Why 30? Because, let me explain that. A 27 subnet provide 32 total IP addresses. 2 addresses are reserved, one for the network ID and one for the broadcast. That leaves 30 usable addresses. Since each department need only 20 devices, the 27 subnet provides enough room while keeping subnetting efficient. It ensures extra space for potential expansion while preventing wasteful allocation of IPs. HR from 0 to 34. So that is actually fixed one. Okay. Until that, range to 255. Okay. And from 0 to 31 is for HR department. And 32 to 63 for IT department. Sales department take from 64 to 95. But here, each department take only 20 the IP address. Okay. But we just make some, how can I say that, some additional addresses. Okay. So here is a quick comparison between public versus private IP addresses. Here's a private and public. So private IP addresses like that, it's all ranges. Okay. all private IP addresses we use it in NAT. Network address transmission. Network address transmission. Let me delete that. Okay. And public IP addresses, all others. Internet facing devices. So I will dip in depth later. Just give a look, okay, take a look, and after that we will get deeper and deeper in this topic. Scenario number 2, home network with IoT devices requirements. One main network plus one guest network. Here is two networks here. Okay. Totally we need 50 devices. Solution. I will give you solution. After that I will explain it step by step. Solution. Main network. Just give it 126 hosts and guest network by that number, by this IP, 62 hosts. Explanation. Imagine your house is a big party with lots of toys, 50 to be exact. You want to split the house into two play areas. One for your family and the close friend, which is main network. One for guests who just come to visit, which is guest network. So you say, one main group gets this IP. That's like giving 126 toy lockers to hold all your friends' stuff. Plenty of space, actually. Two guest group gets that's IP. They get 62 toy lockers, which is still nice for guests popping by. Why lockers? Because each device needs its own space, IP address. That's all you created to save organized zones, so everyone's toys don't mix it up or lost. I will make whole detailed video about subnetting.